Hi guys, welcome to the Captain's Blog. I am not Chris Boden, but I'll do my best anyway. A friend of mine wants an ice press, and he's been storing my dirt bikes for a while, so figured I'd make it for him. So basically I'm planning on taking you through the steps of drafting and putting tool paths to the part, and then prepping the stock and actually machining the part. So here we go. I've already got a new sketch ready. We're going to start a 2D sketch. I usually start on the XY plane. I'm going to make a rectangle that starts on the center. The stock I have is 3 inches by 4 inches, so we're going to make it a little smaller than that so I can take some stock off to make it nice and shiny. So we'll probably go 3.95 and 2.95. I'm going to do a circle in the center there. It will have a 2-inch diameter. We're probably going to have to do that later. Just wanted to get a feel for it. Alright. Alright, finish the sketch. Now we're going to create 3D by using the extrude command. I usually go the other direction. And let's see. Yeah, let's go 2 inches. View, visual style, I like to do shaded with edges, just kind of a personal preference. I'm going to start a new sketch on this face here, draw a circle, 2 inches in diameter, and finish sketch.
You just shooting video of the screen?
Yes.
You want a better shot of the screen?
No.
Okay.
I've already started. What do you want a better shot of the screen for?
It's kind of a jank shot of the screen.
Well, how would you fix it?
That ain't a lot better, but it's a little better. You actually use zoom.
Oh no, not zoom.
It's just hard because you're at this weird angle and stuff.
Right.
My first concern was seeing this being banding or flickering or something, but it's cool.
Okay.
That's quite the block you've got there.
Should I continue or start over?
Do it.
I'll just continue.
Do it with your sexy block.
Alright, so we will extrude that. It'll be a cut, 1 inch. And okay. And hopefully this works. I'm going to fillet the bottom with a radius of 1 inch. Yep. So it creates half a sphere. Alright. And then we've got to put some location holes for the rods that keep the top from falling off as it melts the ice. Make those two equal. Let's see. Probably just dimension them from here.
Are you going to machine the rods out of the block or add in pins?
I'm going to add in pins. I've got a piece of stainless steel that's 10 inches long. I'll just cut it in half. 5/2. You can do math in your dimensions. Same here. And let's see. I'm just kind of guessing on this one. Yeah, let's just do 1.5. the actual diameter of this is going to be 0.5. Looks good. Do an extrusion of these two. They will be cut. And the depth, let's see, we've got 2 inches there. Stability, we'll go 1.5. Alright, so that is basically the entire thing for drafting. There will be another version of this. I'll just do a save as, where these holes go all the way through so that the guiding rod can go all the way through as the ice melts. Yeah, I'm gonna pause here.
Is this to be used in a press?
Yeah, well, not a physical press. It uses gravity, and as the ice melts.
Or just the weight of the block does it? Okay.
Yeah.
Because I was like, you could just thread those holes to fit half-inch bolts.
Yes, you definitely do that, but that's not the intent.
Oh, okay. Cool.
Yeah.
Yeah.
Alright, so continuing on, we're going to chamfer all the edges at 10 thousandths. And you can actually pick edges that you can't see by hovering over them. And apply, and we'll also put a chamfer on these edges here and around back. And okay. So from this point, we can start setting up toolpaths. Go to the cam tab, and the first thing we need to do is set up our stock. I like where the stock point is, so we'll leave it there. We're going to have to do relative size box. The side offset is going to be 25 thousandths per side. The top offset will be 20 thousandths, and the bottom will be 0.105. And that leaves enough room to hold on to it with our Mighty Bite vice jaws. And when you add it all up, you've got the actual stock size, which is 4 inches by 3 inches, and then we'll have to cut it to somewhere around 2 1/8. Hit OK. And that leaves us with that. Alright, so the first thing we're going to do is an outside profile, so 2D contour. Pick a tool, and I have a couple other things open so I can actually pick a tool from those. I already did the bottom section of this, so we'll just pick a tool from there. Use a 2-inch face mill. I like the speeds and feeds on that. Contour, I'm going to select here. And for our heights, for the top height, we're going to select stock top. And for the bottom, we're going to select model bottom minus 20 thousandths. Everything there looks fine. I'm going to turn smoothing on. And then we're going to go to linking, turn on ramp, and we're going to make it 1/2 degree. And the max roughing step down, max ramp step down, 2.5 inches, so it'll ramp all the way down. And change that to 0.5, so it cuts air for less time. Let's see what it does. Yep, that's about what we're looking for. So basically, I'm doing this for stylism. It will create a rectangular spiral tool path, you'll be able to see the tool marks in a spiral all the way down. Simulate that real quick. Yep. The next thing I want to do is a facing operation. Same tool, stock looks fine. Stock top to model top, just takes that 25,000 or 20 thousandths off of there. But again, for style, I want to change the pass direction to 45 degrees. And that just makes it go in a different pattern. Next we will drill these two holes. It's tool number 16, half-inch drill. We have half-inch rods that go through those holes, and you'll end up drilling slightly bigger than that. Pick the holes, and going to be going from stock top to hole bottom minus 0.15. Just get that drill tip all the way through there. We're also going to reorder this. I want this to come pretty much first, so the chips that come out of the hole don't damage the face after it's been faced off and looks nice. Drill wrap it out. This is a really awesome drill, so I'm just going to let it do its thing. Actually, I'm not, because it goes more than 2 inches deep. So I'm going to do a chip breaking partial retract, pecking depth of 1 inch, and make that all the way. Basically, it's just going to break the chip about halfway through. No, I don't like that. I'm going to do deep drilling full retract with a peck depth of 1 inch. Yeah. This way it'll go down 1 inch, come all the way out, throw the chips out, and then go all the way back in. So to change the order, all I have to do is drag it up here. So that'll be the first thing that happens. Alright. After facing, I'm going to do a 2D contour for chamfering. It's tool number 3. Contour is going to be here, here, and here. Do model top instead of stock top, because we've already removed the stock there. It recognizes that it's going to be a chamfer because we chose a chamfer tool. We don't need to pick the chamfer width because we drew the chamfer, but I do want to put a 30 thousandths offset so the tip doesn't, which is kind of weak, doesn't touch the part. And hit OK. Yep. Alright. Next thing I'm going to do is a 3D pocket to clear out the bulk of the material in the hemisphere there. So in the 3D milling section, we'll go to pocket, pick the tool, which is going to be from something I've already done, and it's a almost ½ inch end mill. Now really quick, this is going to be high feed milling, so we'll pull up G-Wizard. And G-Wizard is basically reference and speeds and feeds calculator. So my tool diameter, well, let's see, material is 6061 aluminum. It is a carbide end mill. It's a ½ inch diameter. With 4 flutes, has about 1.5 inches to stick out. I'm going to be doing what's called high feed milling. So low depth of cut, high width of cut, and a high feed rate. So 20 thou depth, almost full. It's actually going to be 495. And with high-speed machining and high chip load, we're going to be going at, I've rounded this to 170 inches per minute. So we'll be flying. 70. For the plunge feed rate, I'm actually going to put that at 50 because it is going to be plunging, and this end mill is center cutting, but end mills don't particularly like to drill. So it only has 20 thousandths to go, so I don't really care, but I want to lower the plunge rate a little bit. Oh, let's see. Give it a bounding box right there. And model surfaces there. Top height is going to be model top, and we'll leave that as is. Let's see. Do a manual step over here. Be 0.495. Roughing step down, we will change this to 20 thousandths. I believe we get rid of that, and we're going to turn off stock to leave because it actually is going to leave stock. Smoothing, basically it just outputs radius commands instead of line segment commands. Makes the program smaller. And for ramp, instead of helix, we're going to change it to plunge. And there we go. Alright. Last thing we're going to do is a 3D contour using a 3/8 inch ball end mill. We're going to change this to 100 inches per minute. I leave everything unchecked except for avoid touch surfaces. Click the touch surfaces box, and there. Basically says the only thing you want to machine is that. Change this to model top. Also going to uncheck everything here. Maximum step down, we're going to make this 5 thousandths of an inch. So it's going to do one pass around, then drop 5 thousandths, do another pass, and it's going to do that until it hits the bottom of the pocket. Turn on smoothing. And I think I changed this to plunge as well. Maybe not. I'll leave it here and see what it does. This is going to take a little bit of time to process. It's a lot of toolpath. Yep, that's exactly what I wanted. So, those are all the toolpaths for operation number 1. Change this to op 1. So we'll go ahead and simulate. And this is going to take a really long time, so I'll probably just speed it up. Says the actual machining process should take 15 minutes and 39 seconds. the toolpath is going faster than the computer can actually keep up with it, and that's the same for all the little blotchy spots you see. Is it's a rendering artifact. Alright, and that's it. Go ahead and save it. And I'll probably make a few tweaks here and there, but when we come back, we'll be starting to cut some stock. Alright, stock's all set up and square. Let's touch off and we'll get to milling. Alright, Operation 1 done. Alright, Operation number 1 is done. Let's set up for Operation number 2. Operation 2 is done. Alright, now time to cut the rods. There we go. So we cut the rods to length, chamfer the edges, smooth them out a bit, and then buff them to make sure they were the correct size. Reamed out the holes a little bit on the sliding part. It needs to be a little bit bigger than the bottom because they need to slide fairly easily. But here you go. One ice press. You know, just another Sunday at the Geek Group. Take it easy.